So I know that a few of you are going to have questions about the homework problem on the back page for division, and I'd like to go over this problem with you. So I'm setting up my box method, which is the method you learned in class last time, and I want you to notice a few things. First of all, it's not just a linear term like x to the 1 power and then a constant. It's still a binomial. There's only two things here, but this is being now raised to the second power. So how do we write this? We can put the x squared term here. I would then put the next power down right here. And there should be some protest. You're saying, but there is no term. There is no x term. Right, so I'm going to put a 0x there. And this is really just going to keep track of all of our terms so they line up nicely, guys. And lastly, we're going to have our constants. That's a -1. So here's how I would set this problem up. Now, we should be able to proceed as before. So in order to get a 4x cubed right here, I would need to have a 4x up top. X squared times 4x gives us a 4x cubed. All right, so far so good. That checked off. Got that. Next, 4x times 0x will be 0x squared. Okay, so far so good. And lastly, you get 4x times -1, which is a -4x. All right, this is good. So far so good. Okay, if we continue, we now see that we have a -4x. In order to get the next term right here, I guess, because these would add along this diagonal, I would need it to add to 10x. So I would need a 16x. 14x. My apologies, everyone. I do teach math. So just a minute. 14x plus -4x will give us a positive 10x. So that works out. Unfortunately, there's no way to get a 14x here out of this. So this quantity won't work for us because you can't multiply 0 times anything to get a 14. So this term, not going to be able to get it. So that 10x is going to be left out, hanging out. We'll see what to do with it in just a minute. The next term should be an x squared term. So we need a -2x squared here. So x squared, we already got that, so this should be a -2. -2, yep, that gives us -2x squared, so that's checked off. And then a -2 times a -1 is a +2. Okay, great. So we now look, we had no way of creating this 10x. So we're actually going to have to use a fraction at this point. So 10x can't be created using these values unless we multiply by some fraction. So we would need a positive 10x, and we need a -9. Well, this is a +2. In order to get to a -9, we need to subtract 11. So this would be my remainder, and I would write that over my divisor, which is this thing, which I can rewrite just as x squared -1. So x squared -1. And this would be our remainder. And so our answer here would be 4x -2 plus 10x plus -11, excuse me. All over x squared -1. So this would be our solution. I want to show you this process also with long division. It works as well. Sometimes I think it works even more efficiently. So I'm going to do that right over here to the side. And long division is set up, in case you didn't watch the other video about that, by taking our divisor, putting it out front of our division house, some people call it, or division bar. So x squared -1, and we're going to put this long thing inside. So we get 4x cubed minus 2x squared plus 10x. Ooh, -9 is so long. Here we go. Got it. Again, same process as you do with long division. How many times does x squared go into 4x cubed? Well, let's go ahead and do this in a different color. X squared can go in 4x times, because 4x times x squared will give me 4x cubed. and we can subtract that. Now, just as in log division, we're going to multiply both of these terms by our new quotient number. So 4x is going to also get multiplied by -1. So we get a minus, actually put it over here, minus 4x. Notice I didn't put it directly underneath this term, and I hope you can see why. This is an x term, this is an x term, so these are going to be combining. If I put it under here, it wouldn't combine with the 2x squared. It's not going to combine with anything that we've written below currently. So now, as in log division, we would subtract. So we end up with, that goes to 0. The negative 2x squared, it just drops down. Easy enough. And 10x minus a negative 4 is 10x, and that's the same as adding 4. So that will be 14x, positive 14x. And that 9 will now drop down, just like in long division. Any terms not used, they drop down. All right, so we look at x squared minus 1. We can go into negative 2x. This first term can go in there, minus 2 times. Minus 2 times x squared is negative 2x. Got it? Minus 2 times negative 1 is in positive 2, and that, of course, goes over here. And you keep, maybe some of you are wondering, what happened to this middle term? Well, I'm glad you asked, in case you did. It's because we don't have that x term in our divisor. If we did, when we multiplied by the x term, it would show up right here. So really, it's a 0x. If we multiply 4x times a 0x, we'd have a 0x here. So it's there. It's just acting as a 0 for now. So yeah, let's go ahead and simplify this. Let's change colors one more time. Negative 2x minus that same negative 2x, that goes to 0 as we wanted. The 14x just drops down. Nothing happens to it. That minus doesn't affect it down here. And then negative 9 minus a positive 2, that's negative, and we're taking away more, so that's going to be a negative 11. So we look at this and we say, hey, is there anything else we can do with this term? Let's see, did I write everything right here? Something says I did. Yeah, I did correctly here. I think I made an error back on the first one. We're going to talk about that error because it's a simple one. So we can't multiply by any whole amount, like a whole number amount or a power amount, in order to get 14x, because this is an x squared term. So we need to multiply by a fraction to get this. And so literally this is going to be our remainder. So we're going to say plus 14x minus 11, and then over our divisor, x squared minus 1. Now, let's go see where the error was, because this looks kind of close. Everything else is matching up. So what did I do wrong here? And in case you noticed, it's because we had it right there. So over here, we're doing all of our box method. We ended up with a negative 4, and we wanted to get up to a positive 10. Well, the only thing you can add to a negative 4x to get to a positive 10x would be a positive 14x. So this should really be positive 14x. Right? Because if you add that to negative 4, you get 10x, which is what this is supposed to be. So that's now corrected. That now tells us that resolves the issue for us. These two terms give us here. And as you can see, everything here matches everything over here. Some of you will find this much more simple, and if you do, great, you can go ahead and use it. This is the box method, of course, and it also worked. It came out with the solution, so it also is a feasible method. Okay, let's see. We can try the one down below. We can try this one. Let's go ahead and do this with the long division this time. Let's just and then we'll do the box method on one of the other ones. Okay, and let's go a little bit faster. So we have x squared plus x plus 1, and then this all goes on the inside, x to the 4th. I'm actually going to write in all of my missing terms here. So there's an x cubed term we don't have, if you see that. So I'm going to put in plus 0x cubed, the minus 4x squared, and then plus 2x, and then minus 9. And this acts as a placeholder, much as if I were doing a problem like, say, 51 divided into, 304 divided by 51. You notice that 0 just tells us there's nothing in the tens place. Same thing here. This is just a placeholder, okay? It's serving the same function for us. All right, so let us go ahead and solve this. X squared goes into x to the fourth, x squared times, because x squared times x squared will give us x to the fourth. Change color for dramatic effect. X squared times x is a positive x cubed, so that's x cubed. Notice it lines up nicely now. And then x squared times 1 is a plus 1x squared. All right, so this we're going to subtract. We're subtracting all of that. So x to the fourth minus x to the fourth, that's 0. 0x cubed minus x cubed is going to be a negative x cubed. And then negative 4 minus 1 is going to be a minus 5x squared. All right, and we continue on. We're going to drop down all of our terms. So we get plus 2x, came down here, and then a minus 9. All right, let's continue. X squared will go into negative x cubed, negative 1x times. All right, I'll just leave that as a negative x. It's the same as negative 1, guys. Please be aware of that. Negative x times x squared will give me a negative x cubed. So notice, these two when I multiply should always equal this because we're going to cancel it out. Negative x times x is negative x squared. Negative 1x squared if you'd like. And then negative x times 1 is a negative 1x. All right. So then underneath, we're going to subtract the whole thing. So this goes to 0. Let's change color again. So that goes to 0 as we wanted. Negative 5 minus a negative 1, which we're losing one of those negatives. It's going to be a negative 4x squared. 2x minus a negative x, we're taking, that's going to be the same as adding another 1 to that, so it's going to be plus 3x. And then lastly, negative 9, and there's nothing to take away there, so it's just going to drop down. So nothing happened to it. All right, great. Let's see. Next, we have 4x squared, negative 4x squared. To get that, we're going to use a minus 4. Minus 4 times x squared gives me a minus 4x squared, so that cancels out. Let's write that a little bit better. Negative 4 times x is a negative 4x. Negative 4 times 1 is a negative 4. All right, let's subtract those. So those go to 0 when we subtract. 3 minus negative 4 is the same as 3 adding 4, so that's going to be plus 7x. And negative 9, you're taking away 4 of those negatives, so you're going to be left with negative 5. All right, so we can't put another whole number up here because if you multiply it times times x squared, you're going to get something bigger than 7x. This can't be factored any further. This is as far as we can go. So we need to leave this as a fraction. So our fraction will be plus and then 7x minus 5 over x squared plus x plus 1. Remember, the divisor goes underneath. And that's your answer. Easy enough. All right, fantastic soundtrack, yeah? All right, moving on to number, I guess, 2 or 3, depending on how the numbers work, and the points don't matter. Here we're trying to find the quotient between these two numbers, polynomials. So again, we're going to try the box method this time, see how it works out. And let's go ahead and get everything listed. So we have 1, 2, 3 terms. That's going to be 3 rows. And let's make this box sizably large, just in case. And 1 and 2. And we know we're going to have at least 1 column. At least 2, excuse me. So that x squared goes here. The 2x. Let's put a plus 2x so we know. And then a plus 3 at the bottom. All right. And then the 2 to the times x to the 4th. Excellent. So this should be 2x squared. It's 2x squared times x squared gives me 2x to the 4th. And then everything else is a derivative, right? We can figure the rest of these out. So the next term, 2x squared times 2x, that is 4x cubed. And 2x squared times 3, oh, excuse me, that was already out. 2 times 3 is 6x squared. All right, and let's go ahead and write that so it's a little more legible. It's saying much, considering, oh, it doesn't want to erase this time. It's even cold in here. All right. That's better, I suppose. Okay, Excellent. So now we have another column. Now, I can tell since this is an x squared term, the next term should be x and then a constant. So I'm only going to need 2 more slots here. So let's go ahead and go some really large boxes. I'll just erase that back in because we won't need it unless there's a fraction, which will just hang off the side, and that's fine. So we don't need any of that. Okay. All right, so next, if this is a 4x cubed, then this term should be x cubed as well. Let's see, if we look up top, we don't have any x cubed terms up here, guys. So that means these need to cancel each other out. So this needs to be a negative 4x cubed. All right. In order for that to be a negative 4x cubed, that would make this a negative 4x. Because negative 4x times x squared will give us this negative x cubed. Got it. Okay. Then everything else fills in down below. So negative 4x times 2x, that should be negative 8x. And then lastly, negative 4x times 3 is a negative, excuse me, let's make sure we do this right. Looks like we missed a power. X times x is x squared. My apologies, guys. And lastly, negative 4x times 3 is a negative 12x. All right, cool. So let's see here. We've been taking care of the cubes, right? They need to cancel out. Next, we need to look at the squares. We need negative 11. So 6 and negative 8 is negative 2. It's not quite enough. In order to get to a negative 11, I'd need a negative 9 here. Okay. Trouble is, you can't get a negative 9 off of this term. Right? There's no way to get x squared times a constant term won't get us a negative 9. It just won't happen. So there's no way to go any further. In fact, we can't go any further. This isn't going to work. We need that in order to solve our problem. So that's going to be actually part of our fraction. And let's see. Next term, we have, let's see. If we put a, oh, no, we're good. I take it back. My apologies. That's right. That's x squared term. Oh, we're good. We're fine. So 6 minus 8, that was negative 2. Minus 9 is negative 11. That's fine. So that works out perfectly. That's minus 9 on the end. That works out great. Negative 9 times 2x is negative 18x. Okay. And then negative 9 times 3 is, let's go ahead and go to brown marker, that'll be a negative 27. Alright, so let's see what we've taken care of. We've got the 2x to the 4th taken care of. This took care of the negative 11. Alright, next we have negative 12 and negative 18x. That combined gives us a negative 30. That works out, negative 30x, so that worked out. And lastly, we have a negative 27, which is what we needed. So this factors perfectly. There's no remainder. It's good to go. So the box method worked out nicely for us there. All right, last one. Let's go ahead and have a look. All right, so it tells us we have a rectangular prism, and it gives us the height of that prism, and they want us to find the area of the base of the prism. So if we take volume, and we divide by 2x plus 1. Well, let's make sense of this. If we have a volume and we divide by the height, that should give us the area of the base. And the reason I know that is because the formula for prisms is the volume of a prism is equal to the area of the base, which they use a capital B for, times the height. So doing some math here, if I take the volume and I divide by the height, that'd be like doing this to my formula. So the volume of my prism, if I divide by the height, well, that should just give me the area of the base. Okay, so this tells me how I should proceed. I should take this volume they've given us and divide it by the height, and that'll tell us the area of the base. All right, we can use the box method, or we can use the long division method. We've used box quite a bit, so I'm going to use long division this time. So we're going to put our divisor out front. And we're going to put our dividend in the middle, underneath, 8x cubed, 14x squared, plus x minus 2. All right, let's see how we do. 2x goes into 8x cubed, 4x to the second power number of times. Let's see what happens when I multiply. 4 times 2 is 8. Yep. X squared times x is x cubed. Grand. We then multiply the 1 times the 4x, and that gives us a positive 4x squared. We're going to subtract that. And when we do, the 8x cubes are just going to go to 0. 14 minus 4 is a positive 10x squared. And then everything else drops down, the plus x and the minus 2. Got ahead of myself there, I suppose. All right, great. So we now look and we say 2x goes into 10x squared, positive 5x times. 5x times 2x is 10x squared. 5x times 1 is plus 5x. And again, we are subtracting. So let's see what we get. 10x squared, so those go to 0. X minus a 5x is going to be a negative 4x. And the negative 2, nothing else happens, there's nothing there, so the negative 2 just drops down. All right, so far so good. Lastly, we see that 2x can go to negative 4x minus 4 times. Minus 4 times 2 is goes into minus 2 times. Oof, this is why we don't use ink. Minus 2 times 2 is a minus 4x. Oof. And then we get negative 2 times 1, which is a minus 2. And the nice thing is, when we subtract, both go to 0, which means this divided evenly. So our answer is that the volume of the area of the base of this prism is 4x squared plus 5x minus 2. And that is the area of the base. We nailed it. All right. Which is perfect, right at the end of the music. I feel successful. All right, carry on.